Hey there, science fans! Today we're diving into the exciting world of machine learning, where computers learn from data to make predictions and decisions. It's like teaching a dog new tricks, but instead of a furry friend, we're training algorithms. One of the coolest tools in the machine learning toolbox is the random forest algorithm. Imagine a forest filled with trees, each one a decision maker. That's what a random forest is all about. Random forests are like super detectives of the data world. They can analyze complex information and find hidden patterns that humans might miss. And they're used in all sorts of amazing applications, from predicting diseases to recommending your next favorite song. So, buckle up, science enthusiasts, as we unravel the mysteries of random forests and discover how they're shaping the future. Before we dive into the forest, let's look at a single tree, or in our case, a decision tree. Imagine you want to predict if your picnic will be rained out. You might consider the weather forecast, the season, and if you see any clouds. A decision tree represents these choices as a series of branches. Each branch splits based on a different factor. For example, if it's cloudy, the tree might lead you down one branch. If it's sunny, you might go down another. Each path leads to a final prediction: rain or no rain. Decision trees are powerful because they break down complex decisions into smaller, easier to understand steps. But what happens when we have a whole forest of them? Let's find out. Now imagine instead of one decision tree, we have a whole forest. That's the basic idea behind random forests. Each tree in the forest is trained on a slightly different subset of the data. This means each tree learns a slightly different perspective on the problem. When it's time to make a prediction, the random forest lets all the trees vote. Each tree makes its own prediction based on what it's learned. Then, the forest goes with the majority vote. This wisdom of the crowd's approach makes random forests incredibly accurate. By combining the predictions of many trees, we get a more robust and reliable result. But wait, there's more. The random part of random forests isn't just about picking data randomly, it also involves randomly selecting features. Remember those factors we used to predict rain? Those are features. In a random forest, each tree only considers a random subset of features when making its branches. This randomness is what makes random forests so special. By introducing this element of chance, we prevent the trees from becoming too similar to each other. Think of it like this. If all the trees in the forest looked the same and had the same branches, they'd all make the same mistakes. But by adding randomness, we ensure that each tree has a unique perspective, leading to a more diverse and accurate forest. Now that we know how random forests work, let's see them in action. Doctors can use random forests to diagnose diseases based on patient symptoms and medical history. Investors use random forests to analyze market trends and make predictions about stock prices. Our smartphones use random forests to identify faces in photos and even tell the difference between a cat and a dog. These are just a few examples of how random forests are being used to solve real-world problems. And as technology continues to advance, we can expect to see even more innovative applications in the future. Section 6, Battling Overfitting: How Random Forests Keep It Real. One of the biggest challenges in machine learning is overfitting. This happens when a model learns the training data too well. It's like a student who memorizes the answers for a test but doesn't understand the material. Overfitting can lead to inaccurate predictions when the model encounters new data. But don't worry, random forests have a secret weapon against overfitting diversity. By combining the predictions of many different trees, each trained on a different subset of data and features, random forests are less likely to be fooled by noise or outliers in the data. This means they can generalize better to new, unseen data, making them more reliable and robust than traditional decision trees. Section 7, Advantages of Random Forests: Why They Rock. So why are random forests so great? Here are just a few reasons why they're a rockstar algorithm: high accuracy. They consistently deliver high accuracy in various tasks, often outperforming other algorithms. Robust to noise. They're not easily fooled by messy or incomplete data, thanks to their random nature. Handle large data sets. They can handle massive amounts of data with many features, making them ideal for big data applications. Versatile. They can be used for both classification and regression tasks, making them a versatile tool in the machine learning toolkit. With all these advantages, it's no wonder random forests are a favorite among data scientists and machine learning practitioners. Section 8, Beyond the Trees, Exploring the World of Machine Learning. Congratulations, science explorers. You've now journeyed through the fascinating world of random forests and gained a basic understanding of how these powerful algorithms work. But our adventure doesn't end here. The field of machine learning is vast and ever-evolving, with new algorithms and techniques emerging all the time. From neural networks to deep learning, there's a whole universe of exciting possibilities waiting to be discovered. So keep exploring, keep learning, and keep asking questions. Who knows what amazing discoveries await us in the future of machine learning? Maybe you'll be the one to make the next breakthrough. Section 9. Conclusion. The future is random, and that's a good thing. As we've seen, random forests are a powerful and versatile tool for tackling complex problems in various fields. By embracing randomness and combining the wisdom of many decision-makers, they offer a robust and accurate approach to machine learning. So the next time you hear the words random forest, don't think of trees swaying in the wind. Think of a sophisticated algorithm that's changing the world, one decision at a time. Keep your curiosity alive and remember the future is random, and that's what makes it so exciting. Keep on learning, science fans.